Well, we have discussed almost all the techniques of differentiation. Now we'll talk about second order derivative in parametric form. See, we are given a question: if x is equal to a cos t plus log of tan t by 2 and y is equal to a sin t, that is, we are given the function in parametric form and we are to evaluate the second order derivative at the particular value of that parameter. Well, we have x is equal to a cos t plus log of tan t by 2. When differentiating with respect to t, what we get? See, derivative of x with respect to t is equal to a times the derivative of cos t is minus sin t. The derivative of log tan t by 2 is 1 upon tan t by 2 into the derivative of tan t by 2. And the derivative of tan t by 2 is simply sec square t by 2 into the derivative of t by 2 with respect to t is half. If we change it in terms of sine and cos, what we get is, see, this is tan t by 2. The reciprocal is simply cos t by 2. Cos t by 2 upon sin t by 2 into sec square t by 2 can be written as 1 upon cos square t by 2, alright, into 1 by 2. This 1 power of cos square will be cancelled out with this. So this will simply give us a times of minus sin t, a times of minus sin t plus 1 upon, in the denominator we have 2 sin t by 2 cos t by 2. 1 upon 2 sin t by 2 cos t by 2. 1 upon this 2 sin t by 2 cos t by 2. 2 sin theta by 2 cos theta by 2 can be written as sin theta. So it will give us simply 1 upon sin t. Now on taking LCM, what we get is, if I take sin t as LCM and if I write this 1 first and then minus sin t upon 1, this will be minus sin square t. Okay, so this gives us a cos square t upon sin t. So we have got the value of dx by dt. The derivative of x with respect to t is equal to a times of cos square t upon sin t. Alright, this is the derivative of x with respect to t. Alright, now we go for y. Y is simply here a sin t. Now, y is equal to a times of sin t. So derivative of y with respect to t is simply a times of cos t. So we have got derivative of x, also derivative of y. We must mark these as equation 1 and equation 2. Now with the help of this, we know that we have derivative of y with respect to x is given as derivative of y with respect to t divided by derivative of x with respect to t. Alright, we have the values of both. So we get derivative of y with respect to x is equal to derivative of y with respect to t is a cos t. So in the numerator we have a cos t divided by derivative of x with respect to t, that is from equation 1. This is actually a times of cos square t divided by sin t. We can cancel cos t with cos t and 1a with a. So simply we'll get derivative of y with respect to derivative of x is equal to sin t upon cos t. Finally, derivative of y with respect to x is equal to tan t. Now here is the most important step. Now dy by dx you can see in terms of t. In terms of t, and we want to differentiate it again with respect to x. So chain rule will be applied. That is the most important thing. Now differentiating with respect to x. See, now on differentiating with respect to x we get, okay, so derivative of dy by dx with respect to x, differentiating both the sides with respect to x, this is what we get. Now the left hand side is simply second order derivative of y with respect to x, that is d2y by dx square, what we need. In the left hand side we will apply chain rule. Simply the derivative of tan t will be sec square t into the derivative of this with respect to x. That is the most important thing. It is not a function of x, it is a function of t, so we apply chain rule. The derivative of tan u tan t is sec square t into the derivative of that which we have treated as u, that is the derivative of t. Now dt by dx is nothing but the reciprocal of dx by dt. Dx by dt, this, the reciprocal of dx by dt. Dx by dt is a cos square t upon sin t. So since derivative of x with respect to t is equal to a cos square t upon sin t, so simply its reciprocal will be dt by dx. So we have sec square t into the reciprocal of this is a cos square t upon sin t. Actually it will give us, if we change all the terms in sine and cos, what we get, sin t in the numerator and in the denominator a times of cos raised to 4t, because sec square t when we reciprocate it, it will give us cos square t into cos square t is cos raised to 4t. This is that second order derivative of y with respect to x, and we are to find the value of this at a particular point t is equal to pi by 3. Now at t is equal to pi by 3, the second order derivative of y with respect to x at a particular value t is equal to pi by 6 or pi by 3. It is pi by 3 in the question. So t is equal to pi by 3 is equal to sine pi by 3 upon a times of cos pi by 3 raised to 4. So this will give us sine pi by 3 is sine 60. Sine 60 is nothing but root 3 by 2 upon a times of cos 60 is 1 by 2, the fourth power of 1 by 2. And if we try to solve it, what we get is root 3 upon 2 on a upon 16. So that will give us 8 root 3 upon a. 8 times of root 3 upon a. This is the answer. C. In parametric form, we'll find first dy by dx by dividing the derivative of y with respect to x. After getting it, we'll differentiate this equation both the sides with respect to x this time. So the right hand side is not a direct function of x, it's a function of t, so we'll apply the chain rule. That is the most important key point in it. Let's take one more question to better understand it. Here again we are given a question in which we are given parametric form and we are to find the derivative of y with respect to x at a particular value of t. Well, let's start as usual. What we'll do is simply first of all we will find the derivatives with respect to t. So here x is equal to a times of cos t plus p sin t. So on differentiating with respect to t, dx by dt is equal to a. The derivative of cos t is minus sin t, plus here the product rule will be applied t into sin t. So t same, the derivative of sin t is cos t plus this times sin t same into the derivative of t with respect to t is 1. This sin t will be cancelled out. This comes out to be a times of t cos t. This is what dx by dt. Derivative of x with respect to t, the reciprocal of this will be needed while finding the second order derivative. Well, also, what about y? We are having y is equal to a times of sin t minus t times of cos t. Here again we differentiate with respect to t. On differentiating with respect to t, we get what we get. Derivative of y with respect to t is equal to a. The derivative of sin t is simply cos t minus, here the product rule will be applied. So t same, the derivative of cos t is minus sin t plus this time cos t same into derivative of t is 1. So this cos t actually will become negative and will be cancelled out, and this gives us a times of plus negative into negative is positive, a times p sin t. This is equation number 1, and dy by dt we have got equation number 2. Now we need derivative of y with respect to x first. So now derivative of y with respect to x is equal to derivative of y with respect to t divided by derivative of x with respect to t, that is equation 2 upon 1. So we have derivative of y with respect to t is a times of t sin t, and derivative of x with respect to t is a t cos t. So this will give us a t cos t. A t will be cancelled out. Sin t upon cos t actually is tan t. So dy by dx, the derivative of y with respect to x comes out to be tan t in form of t in terms of the parameter t. That is the most important point. Now this will be differentiated with respect to x, and in the right hand side we have to apply the chain rule because it is not a direct function of x but a function of t. So on differentiating with respect to x, this time we are differentiating with respect to x. Let's see what we get. D by dx, the derivative of dy by dx will be d2y by dx square. Sorry, dy by dx is equal to derivative with respect to x. We just simply written d by dx. Now the left hand side is simply the second order derivative, d2y by dx square. Now we talk about the right hand side. This is a function of t and we are differentiating with respect to x, so we will apply chain rule. This is tan t. The derivative of tan t is sec square t into dt by dx, and this is nothing but the reciprocal of dx by dt. So this from 1, we will put the value from 1, we will be using equation 1. That second order derivative is equal to sec square t into dx by dt, the reciprocal of this dx by dt, that is 1 upon at cos t. dt by dx is the reciprocal of dx by dt, that is 1 upon at cos t. So this can be written as 1 upon at cos q t. If sec square t taken to the reciprocal. Okay, this is the second order derivative. Now we have asked The value of this second order derivative at a particular point t is equal to pi by 4. So at t is equal to pi by 4. Now at t is equal to pi by 4, we get second order derivative of y with respect to x at t is equal to pi by 4 is equal to 1 upon a. T actually is pi by 4 and cos pi by 4 is 1 by root 2. So this 1 by root 2 whole cube. 1 by root 2 cube. The cube of 1 by root 2 is 1 upon 2 root 2. So this will give us 1 upon a into pi by 4 into 1 upon 2 root 2. So in the numerator we will have 4 to the 8 root 2. 8 root 2 divided by pi into a, that is a pi. This is the final answer to the question.